The new version of NC-Simul can calculate singularity points to analyze toolpaths that could potentially cause wide and unstable rotary movements in 5-axis, like a small tip movement with a high tilt variation. This function is available immediately after decoding before even needing to run a simulation. When clicking on Singularity Point Analysis, it will open a ribbon where the tolerances are to be set. In these, define the limits of the singularity vectors. These values are saying that anytime a toolpath has a value between 0 and 0.001 degrees that results in a rotary motion of more than 60 degrees, throw up an alarm. Next, run analysis to receive a report for NC-Simul's decomposition of each tool sequence. There is a quality of 5-axis column, which is showing what percentage of the tool motion is respecting the proper programmed cutting conditions. And there are also columns displaying the number of singularity and turnaround errors as well, wherein the 60-degree axis motion limit was exceeded. Clicking on a field in the table jumps directly to the location in the G-code where the problem occurred. In the turnaround field, for instance, there is nearly a 90-degree rotation on a single block while machining in 5-axis, which makes it nearly impossible to achieve a good cutting condition in that area. There is a long travel on the machine for a very short tool tip travel. Opening the status window shows the program feed rate of 2,000 millimeters per minute and the actual feed rate achievable on that block not remaining constant and only reaching about 98 millimeters per minute. The machine limits the feed rate due to the rotary axis since the tool tip is moving less than 1 millimeter in that time frame. All of this can be used to find the best possible setup point for the part on the machine table, limiting the distance to the pivot center of the axis, and finding the best orientation to decrease the number of singularity points. By doing this, the number of jerk moves will decrease, increasing the quality of machine surfaces, tool life will improve, and the final product will more consistently reflect the program tolerances.